This video is on the geometry topics of angles, the Pythagorean theorem, and then we're going to look at similar triangles. So by definition, an angle is formed by two lines or rays, and the point of intersection is where an angle is formed. And you're probably very familiar with angles. Many figures contain angles, and we're going to see quite a few questions on the ACT related to angles and their relationships within a figure. So for example, when we're looking at a triangle, we know that there are three angles in a triangle and they add up to 180. Sometimes we're given different information about those angles. They could be a right angle. We could know that we have some acute angles or an obtuse angle. We need to be familiar with all these different characteristics of angles to be able to answer the type of questions that we're going to be given on the ACT. In a previous video, we talked about relationships between angles when we have parallel lines and a transversal. Don't forget about those because we see those quite often in figures. In this example here, we have a trapezoid with four angles. If we're given that we have an isosceles trapezoid, meaning that we have two side lengths that are the same, we know that each pair of angles are congruent as shown. Congruent meaning that they're the same. So we have a lot of information that we can use to help us solve questions about angles, and we'll look at some examples of those things. Next though, let's talk about the Pythagorean theorem. This is a fundamental relationship between the three sides of a right triangle. We're talking about when we have a right triangle. We have other methods we can use when we do not have a right triangle. So when we have a right triangle, the side that's opposite the 90-degree angle is the hypotenuse. And then we have two other sides or legs of those triangles. The Pythagorean theorem states that the hypotenuse squared is equal to the sum of the squares of the other two sides. Usually we have C to represent the hypotenuse, and A and B represent the other two sides. So you may be familiar with hearing A squared plus B squared equals C squared. That's the Pythagorean theorem. Remember when you're using the Pythagorean theorem that the hypotenuse is longer than each of the other two sides. It is the longest side length in a right triangle. Knowing this may help you when you look at your answer choices with whatever you're asked for. Knowing that may help you eliminate some of those answer choices. Anytime you're needed to find an unknown side length of a right triangle, consider using the Pythagorean theorem. In most cases, it's going to be able to help you. So keep that A squared plus B squared equals C squared in mind. We say that triangles are similar if corresponding sides are in proportion, and then also the corresponding angles are congruent. We said congruent meaning the same. So if we're looking at these two triangles, we can see that there is a relationship. The side lengths are in proportion. We have the length that runs vertical, 6 and 3, is in proportion to the one that runs 8 and 4 along the horizontal. This means these two triangles are similar. Each side length, we could take that smaller triangle and multiply each side length by 2 and get the larger triangle. They are similar. One triangle could be smaller or larger than the other, but what we're talking about is that they are in proportion. You could think of them as the triangle has either been shrunk or enlarged one from another, but everything stays in proportion. Sometimes the triangles may not be in the same orientation. They could be and everything lines up just like on our previous graph that we looked at, but sometimes things are rotated differently and they can still be in proportion and the angles could be congruent, but we may have to do some rotating and some thinking almost outside the box. If we can, let's say we hold the triangle on the left-hand side to where it stands, imagine rotating this triangle to the right in a counterclockwise direction to line up the angles that are congruent, as that the ones that are marked by double angles, line those up, and the one with the one angle tick mark. That would give us a relationship here where the side length of 6 lines up with the side length of 12, the side length of 7 marks up with 14, and the 10 would line up with side length x. When we do this, we're able to set up this proportion like we have here on the right, and we can solve for x and know that x is going to be equal to 20. That smaller triangle, we could multiply each side length by 2, and we'll get the side lengths there on the left-hand side. But notice how we do have to do some rotating to get the proper angles lined up together. Let's take a look at an ACT type example dealing with triangles and angles. Try this problem and we'll come back and work it together. The question asks, what is the length of the legs of an isosceles right triangle with hypotenuse of 9 units? So we have some good information in this question that's going to allow us to set this problem up. Isosceles triangle means we have 2 leg lengths that are the same. So we could draw this. We know it's a right triangle. So we have a hypotenuse of 9. We labeled that. The side length opposite the 90-degree angle is the 9. And then we have the 2 side lengths that are the same. That's our unknown, which is x. Now we're going to apply the Pythagorean Theorem. A squared plus b squared equals c squared. And we'll plug in the values that we have for our triangle. And we're able to get that 2x squared equals 81. We want to solve for x. So we're going to take the square root of both sides. And we get that x is equal to 9 on the square root of 2 divided by 2. Answer choice D. Using the Pythagorean theorem is always going to lead you to the correct answer when you're given enough of the side lengths and when you're looking for an unknown side length. But I want to remind you of another property that we might need to make use of when we're talking about triangles. Don't forget your 45, 45, 90 triangle relationships, especially in the case here when you have an isosceles right triangle. When we know we have an isosceles right triangle, we know that we're going to have the 45, 45, 90. So we can set up our triangle as we have here. And we know from the relationship of 45, 45, 90, our side lengths are given as x, and the hypotenuse is equal to x on the square root of 2. We can take that and set that x on the square root of 2 equal to 9, and then we can solve for x. We divide through by the square root of 2. We rationalize, meaning we multiply the top and bottom by square root of 2 over the square root of 2. And that will give us the same answer as 9 on the square root of 2 divided by 2. So that's our 45, 45, 90 relationship. This is just another method you may use to solve looking for unknown side lengths when we have a right triangle.